Hello everyone, I hope you are doing well. So welcome all in this new video. In this video, we will create and build some machine learning classification model using customer churn dataset. Before that, we will do some EDA also. So all this process we will do step by steps. So those who are new to the data science field, please stick to this video. Before going deep dive into video, to those who are new to this channel, my name is Uday Bhan and my YouTube channel name is English Today. If you are someone who love data science and machine learning, then this is the right place for you. You can subscribe to my YouTube channel. Further, without wasting any time, let's start the video. Okay, so I will open the Jupyter notebook and you can see I have given the introduction, then churn, customer churn prediction. So what is customer churn? So customer churn is when customers stop doing business with a company. It can have a significant impact on company's revenue, and it's crucial for businesses to find out the reason why customers are leaving and take steps to reduce the number of customers leaving. One way to do this is by identifying customer segments that are at risk of leaving and implementing retention strategies to keep them. Also, by using data and machine learning techniques, companies can predict which customers are likely to leave in the future and take action to keep them before they decide to leave. So we are going to build a basic model for predicting customer using a Telco Customer churn dataset. So I have given the link of this dataset. You can go and download that dataset. So we are using some classification algorithm to model customers who have left using Python tools such as pandas for data manipulation and matplotlib for visualization. So let's get started. So these are the steps involved. So first step is importing libraries, obviously. The second, loading dataset, then EDA, then removing outliers, then cleaning and transforming data. So this step has some sub steps: one, hard encoding, rearranging columns, feature scaling, feature selection, and then again we have four classification model. So these are some classification model which I have used in this notebook. So let's jump to the first step, that is importing library. So I have imported the libraries which are necessary and which are known for me right now. So I have imported this pandas, sklearn, numpy, seaborn, matplotlib. So I will run this first cell. So wait a second, I will run this first cell and I will do shift enter. So I have successfully run the first cell. Then again the next step is loading dataset. I will run this cell, that is df is equal to pd.read csv, then the path of my dataset. So I will create a data frame called df and I will check the shape of df. So as you can see, the total number of rows are 7043, then total number of columns are 21. Then we will do some EDA in the next step. So I will run this cell df.head. You can see df.head is showing me top 5 rows of my dataset, my data frame. So the columns which are there in this data frame are customer ID, gender, senior citizen, partner, dependents, tenure, phone service, multiple lines. So there are total 21 columns. So the last column is churn, basically that customer has churn or not. So if customer has churn, then this is yes, otherwise it is no. So this is the brief and short introduction about data frame or dataset. So I will run this cell and it will give me the last 10 rows of this data frame. As you can see, the last 10 rows are, so these are the last 10 rows. There are total 743 basically rows. So I will check this again, df.save, using df.save. So 7043 rows and 21 columns. So one thing you can observe, like there are mostly the columns are categorical. Only this monthly charges and total charges and this tenure. So tenure columns, these three columns are basically numericals, otherwise rest are categorical, and senior citizen, this is also categorical, but this is in 0 and 1 form. So one thing you can notice here, we don't have to do one hot encoding on this senior citizen column. So these are the observation we can see. So we have two types of feature in the dataset, categorical and numerical. Most of the features names are self-explanatory. So except for this partner, so you can say partner columns tells us whether the customer has a partner or not. Then dependents, so similarly like partner, whether the customer has dependents or not. Then online backup, whether the customer has online backup or not. So this has three basically categories: yes, no. Then third one is no internet services. Then tenure, so this is the most, I think, confusing one. So tenure means number of months the customer has stayed with the company. So this means number of months the customer has stayed with the company. Then again, monthly charges, the amount charged to the customer monthly. Then last one is total charges, the total amount charged to the customer. So these are the basically feature names. Then total there are 7,043 customers in the dataset and 19 features without customer ID, that is non-informative. Yeah, you can see here this customer ID is basically random. I don't know, I don't think this is some informative for us. So then last is churn column, that is target variable. Most of the categorical features have 4 or less unique values. So this is also one thing you can observe from this data frame thing. Again, we will run this df.size. We'll check the size of this basically the data frame. So this will multiply these two things, and then we'll calculate the total number of basically cell in this data frame. So then again, we will check the df.dtypes. So data types, we will check the data type. So you can see only one senior citizen. This is also a basically a categorical feature, but since it has 0 and 1, though it will show us data type as int. So again, excluding this, we have tenure as int data type. Then we have monthly charges as float data type. Then again, total charges we should have as float data type, but we don't have here as float. It is here object data type. So total charges is given as object data type, but it is a float data type. So one thing you can notice from here, so we will fix it here. We will fix it. So again, I will run this df.columns to check the columns of my data frame. Then again, it will show me that all the columns of my data frame. Then df.info to check the basic information about my data frame. So there are total 7,043 non-null values. Basically, since we know like there are total 7,000 values for the for a particular feature. So as you can see, there are all those 7,043 values are null. So we will see later, like we don't have any null values. So if I run this df.isNull.sum, so it will show me the 0 for all the rows, for all the features. So as you can see, there are no null values. This was okay. Now again, this we will check duplicate values for this data frame. It will show us 0 because you can see there are no duplicate values for this data frame. Then again, basic data cleaning, which we just observed here, like the total charges should be the float data type. So we will change it to data type float. Before that, we will check this data type of the total charges. As you can see, the data type is given in the 0, but if you see something like this, basically 0 in the code, so you can say that this is a object data type. So this is kind of showing us object data type. then we will run this cell and it will change the data type of this basically total charges to the float from the object data type. So we'll check again. So it will show us data type as float 64. Then you can see I have basically made two list, that is categorical feature and numerical feature. It has basically all those categorical feature and numerical features name, and then one is target, that is churn. So I have basically created three different variable for all these features. So we'll run this cell. I will check this skew in the numerical column. Then the skewness you can see here. Then correlation are these, which are basically shown if you run this df.correlation function. So it will show you this basically correlation between all these features. So you can see the correlation between the monthly charge and tenure is 0.247, and similarly for the correlation between tenure and the total charge is 0.8258. so this is what df.correlation function is showing us. Then next is feature distribution. So we will plot distribution for the numerical and categorical feature to check for the outliers and compare the feature distribution with the target variable. So this is what we are doing in this next step. Then numerical feature distribution, we will run this cell and it will show us the numerical features description. And we'll run this cell and it will show us basically the distribution of the numerical feature. So the distribution you can see for the tenure, it is maximum in the starting, basically in the 0 to basically 4 months. Then again it is high for this from this 68 to 70, I can say. Then in the middle, in between, these values are basically in between from 2 to 68 months. I'm guessing, I'm not right, like I don't know it is 2 or 4 or 3, and similarly this 68, 67 or 66, I don't know, but I can say like this is from between 2 to 68, and the values are quite similar for all those months. So this is what it is showing here. Then again the monthly charges. So monthly charges are high in the starting, so in the starting month. So for the monthly charges, so in the starting month these are very much high. Then again it is comparatively low, but also there are some basically more monthly charges for the customers in between 80th month. So this is what it is showing. Then again the total charges. So total charges are basically higher side in the starting, but then again it is basically decreasing. So this is what numerical features tells us, the distribution of the numerical feature. So the next we will look at the distribution of numerical feature in the relation to the target variable. We can observe the greater total charges and tenure are the less in the probability of churn. So we'll run this cell and we will show us this. So as you can see, the blue color histogram is telling us not churn, and the red color is showing us churn. So as you can see, in the starting, there are so many people who have churn, but then it is basically then again it is decreasing. So there are very less people who have churned later. Then similarly for the monthly charges, it is in the starting, I think for the monthly charges it is not that much correlated. It is quite similar for all the values, but there are very less basically churn in the 20th to 65th or 70th month. So these are the relation you can find out from here. Then again corresponding to total charges, there are very high churn in the starting, but it is comparatively very low again with the time being passed. So this is basically corresponding to the target variable of the numerical feature distribution. So then again, categorical feature distribution will run this cell, and it will show basically all the categorical features and their basically the churn rate. So you can see mostly the churn the churn rate is not dependent on the gender. Basically, most of the people who have churn are male and female, and basically the ratio of the male and female gender who have churn is equal. I'm not saying it is equal, but most it is close to the equal. Then again, same to the senior citizen. Basically, senior citizen, there are very less senior citizen who have churn. So as you can see, the zero means not churn, and the one means churn. So there are very less senior citizen who have churned the company. So this is what it means. So again, the partner categorical feature. So those who are having a partner, they are not churning the company. So this is what it means. But it is close to the people who have partner and churning. So we can't say very we can't be very sure like those who are having partner they will not churn. So again, the dependent feature. So those who are having some dependents, they are likely not to churn the company. So basically, they are the number of people who are having dependents are not churning the company, and it is very much higher than the people who are churning. So again, the phone service, you can see those people who are having phone service, they are not churning. And then multiple lines, those people who are having multiple lines are not churning. So these are the things you can observe from here. I will not go to each and every categorical feature. Then again, you can see this paperless billing. Then the people who are having paperless billing are more likely to churn the company compared to those who are basically not having the paperless billing. So this is what categorical feature means here. Next step to look at the categorical feature in relation to the target variable. So we will do this again by running this cell. You can see not churn. So I have basically here given those basically month to month not churn, 2 years not churn. So basically people who have basically this is the feature contract. So again, if you see those who are having contract month to month, so they are mostly uh, not going to churn, and similarly for the 1 year. So the people who are not churning and having some contract is basically higher, and then again those people who are having some contract and having month to month contracts is higher. But those who are having churn, those who are having contract of 1 year and 2 years, they are not churning the company. So from the starting, once again I will basically explain this. So those who have contract with the company, so if the employee has month to month contract, then it is most likely he will not churn. Then again, this data, this churn part, again it is showing like those who are having month to month contract, he will churn. So you can't say like if you are someone having month to month contract, he will churn or not churn. So you can't be so sure with the this month to month contract. Then again, this is 2 year contract, 1 year contract. You can clearly see that there are major gap between 2 year and 1 year contracts. So those who are having 2 year contract and 1 year contract are most likely not to churn the company. So this is what it means. Then again, target variable distribution. I will run this cell, and you can see there are very less people who are churning the company. So in compared to the people who are not churning. So the target variable distribution shows that we are dealing with an imbalanced problem, as there are many more non-churn as compared to churn users. So the model would achieve high accuracy, as it would mostly predict majority class, which basically who did not churn in our example. So in our example, the majority class is the users who did not churn. So the model would have achieved high accuracy um, because of this imbalanced data. So few things we can do to minimize the influence of imbalanced data set. So resample data, collect more samples. The third is use precision and recall as accuracy matrix. So we'll use this precision and recall as accuracy matrix, because we can't collect more samples, and yeah. So for that we will use precision and recall as accuracy matrix. Then the next step is outliers analysis with IQR method. So basically this is what I have written. So this is IQR method by which we will remove the outliers. So this is hard and coded. You just run this cell, and no outliers in tenure, no outliers in monthly charges. So I have given the X as tenure and monthly charges only, because these are the basically the features which are varying. So rest are the categorical variable. So you can see no outliers in tenure, no outliers in monthly. So this is the basically uh, the condition by using which it calculates if there are outliers or not. So and it got defined from here. So we define the 0.25 pointers per quantile, then 0.5 quantile, then 0.75. Basically this is the method. You can explore this IQR method for the outlier analysis. It has so many things in it, so I will not go deep dive into that. I had just run this count outliers uh, function here, and I have printed if there is any outlier or not. So you can see there are no outliers in this tenure and monthly charges features. So we will move forward. Then again the cleaning and transforming the data. So you can see df.drop customer ID. I have already told you this customer ID function. The customer ID feature is not useful for us, because that is a random number, and this will not help us to predict the model in any way. So I will drop this customer ID column. Then again we'll check the df.it. As you can see, there is no customer ID here. So because dropped customer ID because it is not needed. Yeah. So again the next is one hot encoding. We will do one hot encoding. So as you can see, there are so many categorical variable in this data frame. So I will put all those columns names in this column variable here. Then I will write pd.get dummies, and in the data part I will give this df data frame, then columns which are having categorical variable, so categorical features. So gender, partner, dependents, basically all those which are categorical. So you can see there is no senior citizen feature, but also it is a categorical feature, but I have not given here because this is already in 0 and 1 form, and the main idea of this one hard encoding is to have the categorical variables in the some numerical values. So this is already in numerical value, so we don't need to put this in hard encoding process. So I have excluded that. Then I have given the drop first is equal to true. This will drop the original original feature, and it will basically substitute the original to their basically the category, the numerical variable name. So I will run this cell and you will see I have created a new data frame called df1, and I will print the 5 rows of those df1 that df1 data frame. So you can see all the columns are now in are having numerical values. So you can see I will just tell you about this churn feature. So you can see this churn feature, that is our label. So churn means where churn is no, we have got the values as 0, and where churn is s, we have got the value as 1. So basically this is how this one hot encoding works using pd.getDummies value. So pd.getDummies method. So this is what it means. I will run this df.1 columns. It will show us the total columns in this new data frame called df1. So again, the rearranging the columns. So I will rearrange the columns, and I will run this cell df is equal to df this. So you don't need this rearranging the column. You just need to remember what is my output variable, what is my output feature, and what are my input features. So but again, I have done this, so I will run this cell, and I will print the df.1 dot head again, and it will show me the rearranged columns in this cell. So again, I will check the df.1 df1 save. So it will show me the total number of rows as 7043, but total number of columns has been changed to 31 because we have done this one hot encoding. So doing that there only. Once again, the next step is basically this cell, as you can see, I have used this simple imputer method from this sklearn.impute module. So the imputer will replace missing values with the mean of the non-missing values for the respective column. So this way we will basically we can replace all the missing values with their with the mean values of that particular feature. So we'll run this cell, and it will again replace the missing values with the mean of that missing values respective column. So this is done here. So one hot encoding has been done, and again next step is feature scaling. We will use standard scaler here. So I have imported the standard scaler. Then I will define standard scaler as scalar. Then I will do fit and transform on this basically input variable. So excluding churn s column, that is our output variable, that is our label. So rest are our input variable. So I will drop this churn s column here only, and give the rest of the columns as input. So I will basically fit and transform, and yeah, the cell number 35 will fit and transform our input variable. So again, next step is feature selection. So the X is called scale features. So scale features, as you can see, scale feature does not have our output variable, that is our churn s feature, that is our churn s column. So we can see like X, we can put we can say like scale feature is having our input variables. So we will put all our input variables in X, and our output variable, that is churn s, we will put that in y variable. So this is feature selection. We will basically train test split. We will do train test split. So we will write x train x test, y train y test, and we will do this train test split using this sklearn.model selection module. So we'll define test size is equal to 0.3 and random state is equal to 44. You can basically change this random state, or you don't need even random state. But if you want if you want to have same basically output as of mine, then you can set random state is equal to 44. So this is what it means. I will run this cell. I will do the feature selection. Then we have come to the model training and model prediction part. So now we will use X and Y. Sorry, we will use X10 and Y train for training our model. Then we will put this X test to predict the to predict the values of Y. And as we know that we have already the Y values for this X test. So we will basically check the accuracy of the model using Y predicted and Y test. So we will use X and X test, Y train, Y test for this purpose. So I will run this. First, we will run this logistic regression. So we can import the logistic regression from the sklearn.linear model. So from sklearn.linear model, import logistic regression. Then I have imported this classification report, accuracy score, and class confusion matrix. So these are we can import these from sklearn.matrix module. So we will write this sklearn.matrix import classification report, comma accuracy score, comma confusion matrix. So it will import all these basically accuracy score, accuracy measuring methods. So we will run this cell. So I have basically given the name of logistic regression model as log model. So I have basically called this logistic regression as log model. Then I have fitted this X train and Y train values on this log model. Then in the next cell I have predicted the basically Y values for this X test values. So I will run first cell. So it will basically train our model on the X train and Y train data. Then again this next cell, that is so in this cell, like we will predict some value, we will predict Y values for this X test. So I have given the name as Y as predict LR. So I will run this cell and it will show us the predicted values. So basically I will show you the predicted values for this logistic regression. So you can see mostly values top starting 3 values has predicted 0, then last 3 values are also 0, and I will check this by printing the Y test also. So I will run this cell and will show you the Y predict. So starting 3 values are 0, the last 3 values are also 0. So you can see the logistic regression model has predicted our values, our Y values very in a very good, with a very good accuracy. So but for the model's accuracy, we will do this classification report. So we will print the classification report. You can see the precision, recall, F1 score, and support. So these are the basically method which we are using here to check the accuracy of the model. So the precision score is 0.84 for the 0, for the 1 0.65, then recall 0.90, then for the 1 it is 0.53, and the F1 score for 0 it is 0.87, and for 1 it is 0.58. So you can notice one thing, that all these values are very less for this 1, basically churn, and 0 means not churn. So for the not churn, these are the precision score, recall score, F1 score are very high, and these are less for the churn values. So I will run this below cell, and it will show us this this is what we are seeing here, classification report and some visualization thing. So I have already written the code, and will show us the it will visualize this churn no, churn yes. So basically there are the precision score for churn no is higher than churn yes. Similarly for the recall, churn no recall is having more, so it is recalling churn no as the values are here 0.8 0.90. So so similarly for the F1 score, then again for the support. So I will not go into deep dive. Then again we have one more thing by which we can basically predict the model. So a model's accuracy, that is confusion matrix. So I have basically made one variable that is confusion matrix underscore LR. So and I have created the confusion matrix using the y test and y predicted values. So I have run this cell, so it has created the confusion matrix. I will print this confusion matrix here, so you can see. So confusion matrix tells us basically actual versus predicted. So you can see there are 1397 values, which are basically there are 1397 employees, customers, which are uh, not churning, and the model has predicted them they are not churning. And then again there are 160 people or customers who are not churning, but our model is predicting them that they are churning. So this is basically what it means. Then again there are 262 people who are churning, but our model has predicted that they are not churning. Then there are total 2094 people who are churning, but at the same time our model has also predicted that they are churning. So this is what it means. So total 13,097 people they are churning, and model has predicted they are churning. Sorry, I just got messed up. So total 1397 customer who are not churning, and our model has also predicted that they are not churning, and there are 2094 people who are churning, and our model has predicted that yes, they are churning. So this is what it classification confusion matrix tells us. So you can give some more time if you do not basically understand what this means. I will just move on to the next cell. I will print the score of this model on this trained data set. So it is giving us 0.80. Then I will check the accuracy score on the test data set. So it is also 0.80. So it is very good for us to have this much good accurate model. Then again we will use this support vector classifier. So we will import this support vector classifier from this sklearn dot support vector machine module. So sklearn dot svm module, we can import svc from this sklearn dot svm module. So we will import this. Then again we will define this support vector classifier as svc. Then we will fit on xtrain and ytrain dataset, and then again we will predict using svc.predict on this xtest dataset. So I have given xtest as input, and we have got the output as ypredict underscore svc. So this is our predicted values, and this is our ytest is our true value. So we'll print the classification report here. So first basically we have to run this cell. So first we will run this cell. So yeah, this cell has successfully run. Then again we will run this cell. So it has given the precision recall and F1 score and support for this support vector classifier. So you can see the precision recall and F1 score are high for the not churning customers, and it is low for the customers who are churning for the churning. So this is what it means. Then again we'll run this confusion matrix cell, and it will basically show us the confusion matrix for this support vector classifier. So there are 428 people who are not churning, and model has predicted that they are not churning. Then again 265 people who are churning, and model has predicted yes, they are churning. Then 291 people who are churning, but our model has predicted that they are not churning. Then 129 people who are not churning, but our model has predicted no, they are churning. So this is what it means. So I will run this next cell to check the score on the train and test dataset. So the train dataset has more score compared to the test dataset. That is obvious, but yeah, those are very close, so we can't say like model is bad. So this is about the support vector classifier model. The next is prediction using decision tree classifier. So we will basically import the decision tree classifier from the sklearn.tree module. Then again we will call this decision tree classifier, and basically we'll call it as DTC. Then we'll run this DTC.fit to train our decision tree classifier model on our X-train and Y-train data. Then we will predict y values for this X-ray dataset. So X test we will give as input, and it will predict y values as y period underscore DTC. So DTC dot predict will give us the predicted values. So we will run this cell, successfully run it. Then we will print the classification report for the decision tree classifier also. Here you can see the classification report for this decision tree. So the precision, recall, F1 score are less in compared to previous to model for the churn, for not churn, and it is basically equal for this it is low for this for the churn customers. So moving to the next, that is confusion matrix, and I will create the confusion matrix. I will print this here. So total 1262 people, 62 customers who are not churning, and model has predicted yes, they are not churning. And again 266 people who are churning, and model has predicted yes, they are churning. And similarly for the people who are not churning, but model has predicted they are churning. So there are total 295 people in such category. Then again one more thing, that is model has predicted they are not churning, but they are actually churning. So there are 290 customers who are doing this. So this is what this basically confusion matrix tells us. Then again next is score of train and test data. So you can see this model has basically score of 0.9987 on the train dataset, but it is very low on the test dataset. So you can see the model has overfitted here. So we will not use decision tree classifier in our actual work for this basically for this predicting customer churn. But again the next is Knn classifier. So we will import K-neighbors classifier from the scalar.neighbors module. We will define K-neighbors classifier as Knn. I have given the number of neighbors is equal to 30. You can basically give some other values, but yeah, for the right value we should use that elbow method, and I will explain it later. Then again we will do this Knn.fit on X train and Y train, and it will train the model. Then I will run this cell. So next is prediction. So we will use Knn.predict method on the X stage data. So it will give us the predicted values for this Knn model. So the predicted values are stored in predict underscore Knn variable. So this is what it means here in this cell. Then again I have written this cell, and it will basically calculate the error rate. So in this Knn classifier, so it is running here. So I will print the error rates versus k graph. So if the k is close to 1, the error is very high. Then if k is basically close to 20, 25, then 30, so it is the error rate is decreasing. So error rate is minimum here at where k is 30, 32, 35, 34. So you can take any values between 30 to 34. Similarly, you can observe here, this is 30, this is 31, this is 32, 33, 34, 35. So you can take these three values, 30, 32, then 34. So these are the values where the error rate is minimum. So you can take 30, 31, you can take 30, 32 and 34 as your k neighbors in this Knn classifier model. So this is what it means. So this is what I was showing you. This is somewhat like elbow here. So if you see that this is the basically part where uh, this graph is shown like the elbow of our hand. So this is why we call that we can basically get the right value of k using this elbow method. So where the graph is most bent, k value of that particular point is the right k value for our Knn model. So this is what elbow method means. I will basically explain all these things when I will basically cover all these machine learning model step by step. So I will cover all these machine learning model as individual. So I will go in detail in all those videos. So I will run this classification report for this Knn model also. You can see this time basically the value for the churn is higher. So precision, recall and F1 score are higher in compared to the other previously used machine learning model. So this is what it means. Then next is confusion matrix for the Knn also. We'll run this confusion matrix code. As you can see, there are 170 people who are not churning, and the model has predicted yes, they are not churning. And there are 187 people who are not churning, but the model has predicted no, they are churning. Then there are 252 people who are basically churning. The model has predicted they are not churning. So this is what it means here. And there are 304 people and the customers who are not churning, and our model has predicted yes, they are churning. So this is what it means here. Then the score for the white on the train set, and then a score for the test set. So a score for the train set is 80, and the test set is 0.79. So it is quite close. So you can say like this Knn will also work on this data set. All right, so we have come to the end. So conclusion. So first of all, I will say thank you for sticking with me until the end. So if you are interested in learning more about this data set, you can explore other machine learning classification models such as EDA boost, gradient boosting classifier, cat boost classifier, XGBoost. So there are so many classifier which you can try out. So one more thing, you can try tuning the model's hyperparameters using techniques like grid search, CV. So I'm not going into detail about those topics, but if you are interested, feel free to explore them further. So thank you everyone. Bye bye. Take care.